This is numbers 19 through 22. Number 19 says, what's the length of the diagonal inside the rectangle? What we know about a rectangle is opposite sides are congruent, so I could transfer this 10 to this side. We're trying to find the length of the diagonal, which is the line that cuts across the middle from opposite vertices. So here, if I were to redraw this, I know rectangles have right angles. This is going to be 20 degrees, this is 10, and this is x. So now we're just going to find that x. Notice we've got opposite and we've got hypotenuse. So sine of 20 is equal to the opposite over the hypotenuse. Now we're going to solve for x, so multiply both sides by x, so these cancel. I'm left with x sine of 20 is equal to 10. If I divide both sides by sine of 20, then the sine of 20 will cancel, and in my calculator I'm going to do 10 divided by sine of 20. And that leaves me with approximately, to the nearest whole number, 29 units. It says, what's the second largest angle in a 5, 12, 13 triangle? Is this acute, right, or obtuse? Well, we learned how to decide which one of those it was by taking our c squared and comparing it to our 2 legs squared. Okay, so here we go. We got 169 is equal, well, maybe equal to, we wanted the relationship to 25 plus 144. Now, if I add those together, I get that they equal each other. So first off, this means I have a right triangle, which is perfect, because if we draw this now, we've got a 5, 12, and 13. It says, what is the second largest angle? Well, you want to look for the second largest side then, because the second largest angle is going to be opposite of it. So here it is. This is going to be 12, and opposite of that is going to be the second largest angle. That's what we're going to solve for. So let's just do this with, let's do cosine, because we haven't really practiced that a lot. So we're going to do cosine of theta is equal to the adjacent over the hypotenuse. Now to solve for theta, we're going to move cosine this way, which means we need the inverse cosine of 5/13. So that's what you're going to put in your calculator, inverse cosine of 5/13. And we get approximately 67 degrees for the second largest angle. Number 21 says in a right triangle, sine of x, let's go ahead and put an x, is 6/10. So that would be opposite over hypotenuse. And so if I did Pythagorean theorem or recognize this is a 6, 8, 12 triangle, now I can do tangent of x. Tangent of x will be opposite, which is 6, over adjacent, which is 8. And that would simplify. 2 goes into that 3 times, 2 goes into that 4 times, simplifies to 3/4. It says, what is the perimeter of an equilateral triangle with an altitude of 12 square root of 3 units? So equilateral also means we've got equiangular here, so we've got a 60 degree here for each of these angles. We drop an altitude. We're saying that that is going to be 12 square root of 3 units. And we're trying to find perimeter. So again, we want to know what that longest side is here, so I'm going to put an x there. If I were to take that as a right triangle, then here this is 60, this is 12 square root of 3, and this is x. So I've got opposite and I've got the hypotenuse, so that means we've got sine. Sine of 60 is equal to the opposite over the hypotenuse. So let's solve for x, multiply on both sides, so we have x sine of 60 is equal to 12 square root of 3. Then we divide both sides by sine of 60, and those cancel. And so in our calculator, we're going to do 12 square root of 3, and then we're going to divide it by sine of 60, and that leaves us with a x of exactly 24 units. Now we're trying to find the perimeter, so there's 3 sides that are the same, so we want to do 24 times 3, and we're going to get 72 units.